Hey, everybody. Thanks for being here. My name is Eric Bourne. I'm an architect at SAS R&D, and I'm joined by my friends Yiqing and Ishwar. And we're here to talk about some experiences we had last year and this year in deploying VIA in their production environment. All right, so I'm going to go through the agenda pretty quickly here. So we're going to start off talking about a challenge, all right? And really, it's about, like I said, our experiences in deploying VIA in a large-scale enterprise environment, right? What kind of stability and performance issues did we hit? And then we're going to dive into, well, then how did we fix that, right? What was our solution to get past those stability issues and really just improve the overall quality of the platform itself, right? After that, Ishwar is going to show us a little demo, and then we'll follow up with some Q&A. So I'll let Yiqing, all you.
Thank you. So my name is Yiqing Wang, Ishwar and I from Liberty Mutual. I'm a senior solution architect. So we work for Liberty Mutual. Liberty Mutual is like a large insurance company, ranked in 91 among Fortune 500, 40,000 employees, and fourth large commercial line writer in US. Now next, I'm going to talk about our SaaS journey. Liberty Mutual is a long-time SaaS customer. So we start from mainframe SaaS, desktop version, then go to the 9.4 SaaS Grid. Then recently, we migrate to SaaS VIA. So if you use 9.4, you know the architecture is totally different than SaaS VIA. So SaaS 9.4 is a thick client, has multiple tiers, metadata server, workspace server, and the web tier. So for the performance tuning, it's normally like a vertical. You can add a lot of memory CPUs to boost the performance. But when we move to SaaS VIA, the framework is totally different. SaaS VIA is a natural cloud data platform. It's all Kubernetes driven and has dozens of microservices. So to tune the performance, it's not just adding CPU and the memories. A lot of pod microservice related parameters, and we can tune. So that includes how we auto-scale the pod and how we make the system pod more robust. When we working on SaaS VIA, first migrate to SaaS VIA, we found the out-of-box installation and these default parameters not going to work to serve like 1,000 SaaS users. Then we have a lot of concurrent process, batch jobs, and the large user base running different kinds of size jobs. So before we do the system tuning, we always run into a lot of issues, like a pod run out of memory, user logging to SaaS VIA, slow login. It takes about more than like 1.5 minutes to just getting SaaS Studio start up. When we administrator check the OpenSearch, we found a lot of errors in the log. So a lot of them related to system timeout, the user performance related, and we see the tons of messages in RabbitMQ, which is internal message system. These symptoms means our environment doesn't have a very good health, and we get a very poor user experience at the beginning. Then my colleague, Eric, worked with us to tune the environment. Now they're going to talk about how we solve these problems.
All right. Thank you, Yiqing. All right, so as Yiqing just said, we saw a lot of issues, right? Pods were restarting, pods were failing, poor performance, users seeing runtime errors, just not the best user experience, right? So how do we go about trying to solve a problem like this? All right, well, we'll start with something I'm calling the VIA optimization lifecycle, where it is a constant cycle of monitoring, optimizing and validating, okay? The key thing when you're dealing with a VIA deployment that is running at the scale that they're running, hundreds of concurrent users, thousands of jobs running a day, every day, right? It's a continuous process, okay? You want to monitor so that you're observing the system, right? Tune, where do I need to make some tweaks, okay? Validate that those changes were successful, and then repeat the process, all right? So why is this important? Well, as I said earlier, users were having just kind of an overall poor experience, right? And so really, number one is we needed to gain the trust of the users and just elevate their experience as much as possible. Make sure that your jobs and your overall performance is running as optimally as possible. Reduce the number of runtime areas. Obviously, that'll help with user experience. And then lastly is leverage cloud resources to their fullest, right? So when is this important? Well, short answer is it's always important, okay? Think of it, I mean, you want to consider, monitor just tuning and configuration before you even deploy VIA, right? So it's during that initial planning phase, like I said, before you even deploy any bit of the software. Well, then it's onboarding new users. Maybe you've increased from 50 users to 100 users to 200, right? You want to revisit how is VIA configured? Maybe you need to tweak some of the parameters. When your volume of workload increases, right? Maybe you are now going from 100 jobs to now I'm running 1,000 jobs a day, right? And then lastly, what about when you're updating software versions? When you're going from one VIA stable release to another one, or one LTS to another LTS, right? So the key point is it's a constant cycle. All right. So when you think about optimizing and configuring VIA, there are three different areas, well, multiple areas, but three key areas are just your underlying infrastructure. By that, I mean like your Kubernetes cluster itself. Are your VMs sized appropriately? Do they have the right CPU, memory, and so on? There's the underlying VIA services, or the microservices that VIA is running within. And then there's also your SAS code, right? Do you have the right storage options configured? Is your SAS options, mem size, sort size, are those all set properly? For this presentation, we're just going to focus on the VIA services, okay? Too much, we could be here for another hour, 2 hours if we're going to talk about everything. So we're just going to focus on services alone for now. All right, so first section, monitoring. So as we talked about, it's a constant cycle, right? And so when we think about all the issues that Yiqing was talking about, slow login times, runtime errors, backup failures, and so on, how do you know where to start, right? VIA has over 100 pods in it, and so it could be a little daunting to figure out, well, which thread do I start pulling down, right? First thing is, listen to your users. What web apps are they using? What kind of issues are they seeing? Ask them about performance. Is their login times taking longer than they expect, and so on. But always listen to your users, number one. Look at pod logs. Look at, are your pods restarting, okay? And then also use some monitoring tools to just look at overall metric utilization or metric collection. All right, as for tools, what kind of tools do you want to look at? Could be as simple as just some kubectl commands, right? Just some really basic kubectl commands to look at logs, look at pod information, and so on. There are several different variations of monitoring tools, monitoring applications. For instance, SAS has a GitHub project called SAS VIA for monitoring. That could be deployed in your cluster to help for monitoring. SAS VIA auditing. It's a service to help really give those kind of diagnostics of what are your users doing on the system? What kind of activities are they doing on a day-to-day basis? And then there's some third-party tools like K9s and Lens that could also help. All right, so we're going to look at just some manual kubectl commands to start, okay? So this is just from a deployment I have of, and I'm just doing a real simple kubectl get pods. You can see here just listing, now obviously not all the pods in the system, but the first 12 or so. The key area I want to focus on is this restarts column. And why is this important? Is because a benefit of Kubernetes is if Kubernetes decides that a pod is using too much memory or is using too much CPU, it might decide to restart that pod for you, right? To help relieve a little bit of the pressure. That's great on one hand, but on the other hand, that can impact your user session, right? Any active user session who is hitting that pod could experience some downtime, essentially, right? So we really want to look at what's the underlying reason why a service is restarting. All right, so now I'm going to look into one of those services I was restarting was SaaS Compute, okay? I get this from just a very simple kubectl describe pod command. And here, what I want to focus in on is this last state, this little blue box here, where it says the last state was it was terminated. It gives you the reason, which says, well, it was an OOM kill. That means it ran out of memory. And I can see that it restarted a total of 9 times and gives me the date. So again, the last couple slides really just gives you those first bit of nuggets to start looking into, like I said earlier, where do I need to start drilling into, right? So if I start seeing a pod that has got an OOM kill, that's my first clue. That's something I'm going to start needing to look at, okay? In addition to just some kubectl commands, I could also use Grafana, for instance. So this is a simple graph here that's showing services like SaaS Batch and SaaS Launcher. And you see on the left-hand side, it's showing overall CPU usage as compared to the pod's limit. And on the right, it's its memory usage, okay? Anytime you see a big spike, like we see on the left-hand side, where it's coming close to that CPU limit, that's basically a signal to us that says, well, this pod is really using too much CPU. Again, like what I said earlier, Kubernetes could decide to just terminate that pod, and that's something that you want to look out for. Okay? So now I'm going to pass it over to Ishwar, and we're going to talk about optimizing VIA.
All right. So, I mean, in here, I think our primary goal is pretty simple. Like, how do we stabilize the SaaS environment and ensure it could reliably support the level of workload the business required? So we focused on 3 key objectives. So reducing the frequency of the pod restarts, minimizing the out-of-memory kill events, and tuning the resources so the platform could handle peak concurrency with confidence. So to achieve this, we took a focused and iterative approach. So the first thing is we tune the critical stateful sets to improve overall VIA stability. And then, so we enabled a high availability across the deployments so workloads could continuously, seamlessly work through even if a pod or node failed. And then we also increased the memory and CPU limits in areas where the platform was under provision. This significantly reduced the out-of-memory terminations and improved the performance under load. And the third thing that we did is we look at the JVM configuration, right? We applied the tuning to it, optimize the heap usage and garbage collection behavior, reducing the Java-related service errors. And finally, we kind of like increased the service token timeouts to better support the long-running user sessions so that user doesn't complain about, I'm getting kicked out, right? After 15 minutes, something like that. So now, after applying these changes, what are the results? So, once these changes were delivered, it's clear, we kind of like have a clear measurable results. Now we can now support 12 times more concurrent jobs with significantly higher concurrency throughput. The platform consistently handles more simultaneous users and parallel workloads without performance degradation. Just as importantly, user trust has improved. Sessions are more stable, interruptions have dropped dramatically, and overall platform reliability is noticeably better. The environment is now well aligned with the organization's workload demands and future growth. With that, I'll just have Eric speak to the tuning summary.
Thank you. All right, so thanks to you, Ishwar. So really, there are 3 areas that we wanted to focus on, right, as Ishwar pointed out. The first one is replica instances, right? VIA comes with an overlay that's called like Enable HA, which by default will let you increase the number of replicas for all the services from 1 to 2. And that's great because it gives you high availability. If one pod goes down, you have another pod that can take the load, right? But where that also helps with is just overall kind of load balancing of incoming requests, right? When you have multiple number of replicas or number of instances of pods running, the more it's able to divvy up between them, right? So instead of bogging down a single pod, you're able to divvy it up to 2 or 3 or pods and so on. Okay, so that was kind of the first thing that we wanted to look at. Second one is resource limits. Okay, adjusting CPU memory limits is essential when you're looking at like the amount of workload that they were seeing. Again, we're talking hundreds of concurrent users, thousands of jobs running through the day, all right? So looking at the various CPU and memory limits of all your pods within the system is absolutely critical, okay? And then it's service configurations. VIA is kind of a mix where we have some services that are written in Go and some that are in Java. Well, the ones that are written in Java, we really have to look at kind of tuning the JVM, making sure that the Java heap size is configured properly. And then there are several different connection pools, whether you're connecting to Postgres, connecting to LDAP. All of those need to be fine-tuned based on the workload that your system is using. Now, the good news is VIA ships with defaults for all of these. Okay, so by default, and VIA will keep tweaking these defaults as needed, but all of these have, whether they're patches in place or default configuration in place to set these up for you out of the box. Okay, but then to help when you need to go beyond what some of those defaults are, that's where we've created this. It's a GitHub repository called SAS VIA Tuning. Okay? The idea behind this is we're taking those default values that VIA gave us, and then we're increasing them. Again, especially for those types of environments where your workloads, you're really hammering the system. Okay? The idea here is it's really to take that guesswork out of the equation for you. So you don't have to pick and choose which pods do I need to tune. All of those recommendations are in here, okay? Now again, this is for the SAS VIA platform itself. We have plans to add in solutions, but for now, it's just the platform. So again, if you think of your compute tier, your authorization, identity management, authentication pieces, all of those components within VIA have additional tunings, again, to meet the demands of your users. Yeah, and that's that. And then, all right, so now we're come to validating VIA. So we've talked about 2 parts of that cycle, right? We've talked about monitoring, we've talked about optimizing, and now the last part is validating, okay? What's key when you're making any kind of changes to the system are, especially in a production system, how do you verify what you changed is working? Because you do not want to impact your user active sessions, your jobs, or anything, right? So you want as minimal impact as possible. Well, to help with that, we've created another GitHub repository. It's called the SAS Validation Scenarios. This is an automated test suite that we're putting together right now to look at not just functional validation, but also performance validation. All right, so imagine you are updating from one release of VIA to another, and you want to run some automated tests to verify that, okay, I just updated the previous LTS to the new LTS, but I want to verify that my functions in SAS Studio are still operating correctly, or this set of jobs are still running properly, okay? Or what if you are planning on more users coming onto the system, and you want to prove, okay, can I actually have 100 users log into SAS Studio at a time, okay? Both of those scenarios, whether it's functional or performance, can be validated or can be tested using this, this validation scenarios project, okay? It's an open source project. Ishwar is going to talk more about it in a minute, but leverages Playwright to actually do the automated tests and Locust to do all the kind of testing at scale. And yeah, that's it. So, Ishwar?
Yeah. So I think everyone here is pretty much familiar with the 2020, right? The COVID, that changed the lives for most of the people. And so personally, me being a full-time employee for Liberty Mutual suddenly thought, I'm going to think like a startup company, right? Everything should be a push button. If you're on board with it, you can stay with Liberty Mutual. If not, you can go out. I mean, they didn't literally say it, but, you know. So, I mean, Abby, I think it's not going to impact on my performance review, I think. So, okay, yeah. So with that, So right now, currently, the Liberty Mutual policy is like, you cannot access anything manually. You have to have the automation, right? It doesn't matter whether you are kind of like deploying anything, any resources in the AWS, anywhere you want to access the S3, everything, right? So that's where, on top of that, so SaaS, right? So they came up with an idea like, oh, we're going to give you one more pain point. Like, we're going to do the release on a monthly, right? Come on. So we are already dealing with Liberty Mutual. Now we have to deal with SaaS, where we have to validate every month, every time we do the upgrade. So how do we dealt with it? So, I mean, it's pretty simple. I mean, everyone here knows that as SaaSwire follows a monthly release cycle, and every release kind of like changes the APIs, the services, and the user workflows. So before applying this update to the production, we need to validate not only the functionality, but also the performance stability of it. So that's where, historically, much of this validation was run manually. And, so we have to kind of like change the way that we are doing the validation here. Like, the reason for that is there is a production level concurrency, and which means like testing with 100 plus concurrent users, number of workloads. So that's where we came with an approach like it's an open source. I think, I'm not sure if it is publicly available, but I think eventually it's going to be. So we collaborated with SaaS, and that's where we kind of like use Locust, Playwright, and Kubernetes, right? So Locust is more like, if you think of it, it's more like a distributed load generation. Like, if you want to run a particular test, right, with hundreds of users, the Locust comes into the play. The Playwright is more to kind of like automate the UI experience. So in this case, let's just say what the user does. He authenticates into the SaaSwire, gets into the SaaS Studio, open the My folders or any folder that he or she wanted to, and run the SaaS program, right? So that's pretty much. So we pretty much use the Playwright for that, end-to-end UI automation. And then Kubernetes is the underlying platform where we could run at scale, right? So I'll show you the demos, but some of the results that we found is once we applied this into the validation, automated the validation test, and applied this into the environment, so we can now run the automated performance tests with concurrent users, executing the real world via workloads. And I think the validation time pretty much has dropped dramatically. I think before it used to be days, kind of like, from the non-prod to production. It used to take days to kind of like, plan for it, do the manual tests, everything end to end. And also it's kind of like has to be done across the board. If it's a big team, it's kind of like a pain in because the level of knowledge on each individual is quite different, and the way they interpret the results is different, right? So we need to have a standardized test for it. So, and most importantly, we also need to catch the performance regression, right? So before it updates before it kind of like reaches the production, and to reduce the risk and increase the confidence in every monthly release. So what we built is, so we kind of like build a Kubernetes native test framework using the core, we kind of like combine 3 open source technology. As I said, Locust for the distributed load generation, and Playwright for the UI automation, the Python for the flexible scripting. So, and all this feeds the performance benchmarking and trending, so we can compare the releases, detect the regressions, and understand the capacity limits between, let's just say, I did the O2 and then I did the O3. So I could pretty much compare, the O2, does my performance went up or down, right? So some of the business value is it's kind of like fast adoption. Now I think we are pretty much confident anytime SaaS release a cadence updates, we could pretty much, around 90-95% of the time, pretty much seamlessly kind of like drive from the non-prod to the production in no time. And then the risk detection. So this is where like we are now able to detect the issues before they reach the production. This kind of like gives much greater confidence when applying the monthly cadence as well, and the data-driven insights. So this is pretty interesting. So by trending the performance across releases, so we gain actionable insights for capacity planning and long-term strategy. And we can clearly see whether the workloads kind of like are becoming heavier, more efficient, or regressing over time. And now the efficiency gains, right? So automating all these validation tests kind of like free up most of the engineering time. And now we could kind of like, in a push button, we could pretty much do all these validation tests, and we could, offload this to our offshore team where they kind of like run these validation tests every time we do the upgrade. And we are pretty much like, as an engineering team, try to focus on the deeper analysis, other tuning stuff, so that we could make the what you call the high performance, high value improvements to the systems. So I will kind of like explain the takeaway at the later. So I'll just walk through the demo now. So what you guys are seeing in here is Visual Studio Code, right? And on the left-hand side, there are so many validation tests that we built. So initially, we thought of doing something. I mean, I thought it's crazy, but Eric is like, it's too much to kind of like do with 15, 20 users, because it's kind of like looks clunky on the screen. So all I'm doing here is just executing the script, right? So this is all automated. So it pretty much opens a browser, and if you guys can see in there, it pretty much pops in with the credentials, right? So in Liberty Mutual, we pretty much use the OIDC as an authentication mechanism. So it types in the ID, and then it masks the password, types in the password, and once it's done, it kind of like asks whether this is an administrator, yes or no, right? Everything is automated in here. And then once that's done, it kind of like navigates to the SaaS Studio. And that's where, so I think most of the people who are familiar with the SaaS Wire, so once you log into the SaaS Studio, on the right-hand side, you see that there is a compute context that needs to load in order any user to perform anything, right? So run a SaaS program or whatever it is. So it's wait for it. Once it acquires the compute context, and then it goes to the SaaS content. And then in this case, I have my SaaS program that I wanted to test in my folder. So it opens it, and then it goes to the hello world.sas, right? It opens it, and it runs it. So once it runs, it pretty much kind of like, wait for the results. And once it has the results in there, I mean, it's just a sample program. Just wanted to say hi to SaaS. So once it's done, the browser automatically gets closed. And in the Visual Studio Code, it pretty much gives you the summary on whether the validation passed and the duration it took for the user to kind of like go through the entire process. I think somewhere in here, I think it's 100 seconds, something like that. So all of this that you're seeing here is pretty much automated. So similar to that, so this is a multi-user. So I thought we kind of like wanted to do 15, as I said before, but 3 looks better for the screen. So this similar experience. So now I pretty much run the same thing. So it goes through the same mechanism. And if you see in here, there are 3 users that pops up. So 3 different users, 3 different browsers that pops up. And then you could, it kind of like follows the same mechanism. Like each individual user gets authenticated. And once the user gets authenticated, they have to navigate to the SaaS Studio. And then wait for the compute context to acquire. And then it goes to the Hello World program and pretty much runs it and gather the results.
Is it running?
Yeah, it is.
Okay.
It's,
So it pretty much takes time because it's 3 users, right?
What's that?
It's 3 users, right? So
yep.
it takes
Yeah.
time.
Yep.
Yeah.
There we go.
Yeah. So once all these 3 tests are completed, the browsers get closed. And also one interesting thing is right now, just for the user interface, I'm pretty much showing this as the headless mode as true. That's the reason you kind of like seeing the browsers, but you don't need to have the browsers. So in there, you could pretty much see the duration for each individual user to take time, right? So think of this when you have 100+ users, right? You wanted to test, regression test your environment, you pretty much click run it. And I think, so we tested somewhere close to 20+ users, and the average mean time is 95 to 105 seconds. So that kind of like tells you, how your environment is performing, right? So with that, I mean, I wanted to everyone to take one key takeaway, like automation paired with open source kind of like enables the enterprise grade performance testing at scale. And this approach isn't just faster, it's much more reliable, much more repeatable, right? And it doesn't require to kind of like, so a new individual came into your team, right? So it's pretty easy to kind of like have them go through the code, but at the same time, if it's in a rush, they could pretty much run it, have everything in there, have this loaded into the database, and it should be good. So one other thing is right now, can I say the validation test that we built?
Yeah, you can.
Yeah. So right now, I think we pretty much have most of the stuff that an user do in the SaaS Studio, we pretty much have the automation for it. We could validate it. And now we are kind of like tackling the environment manager as well. Kind of like, as an example, I did my upgrade, right? I wanted to check the jobs that ran previously and did it fail or not, right? After the upgrade. So I could do that. I mean, right now we built a validation test for that as well, and it's working great. So the next step for us is kind of like to have all of this translate into a CI/CD pipeline so that it's a push button and you could pretty much automate anything that you want. All right? With that, any questions?
Okay.
Hi, it's nice to see you again. With respect to capacity planning, when you are doing this testing, right, are you making sure that your Kubernetes cluster is already scaled to do this, or you are letting it to scale on its own?
So the testing, okay. So the testing that we are doing, so the testing that we are doing in here, we kind of like create a separate namespace for it. Even though it runs in the cluster, it doesn't load you much because all of these are lightweight open source tools, right? So far I didn't see anything that kind of like impacted the environment.
No, I'm talking about the pods. Let's say we
Oh,
have...
the pods. I want to speak on it.
Yeah, I'll start by saying a couple things. So this isn't going to answer your question, but real quick, there are multiple ways to run the validation scenarios. What he showed was just kind of outside as a local environment, running it from his local machine, right? You can also run them inside the cluster itself, okay? And then to handle the load, there are multiple ways to do it, I guess. It's probably best to increase the number, auto scale beforehand or something, right? Because if you let say, your cloud provider do the auto scaling for you, that's going to impact the amount of time it takes for users to session and so on. So if you really want to scale it or test it such you're testing 100+ users, I'd probably say increase the nodes first, right? But yeah.
Thank you.
Sure.
Other questions? Can you go back to the previous screen, to the VS Code screen? So in each one of your scenarios there, and you showed the 3 for the hello world.
Uh-huh.
Each one of those is written in Python. Have you ever considered writing them in SAS instead of Python to do your performance testing?
No, we haven't. So the thing for us is, the way that we thought is, so we wanted to run these tests agnostic to a tool, right? So that's the reason that we picked the open source. right? I mean, so in this world of AI, it's not pretty tough to convert it, all of these to the SAS code. But because all of these that you are seeing in here, it's pretty much like calling the APIs, right? So, and there is one validation test that we built using the batch CLI, right? So I wanted to check to see if the batch jobs are running fine, right? So we built a validation test. What it does is it pretty much uses the batch CLI, right? It does uses the batch CLI, but at the end of it, it pretty much running the SAS code, right? So the user SAS code, whatever it is, right? So that's where we thought, our main focus is it should be agnostic, right? So, we don't have to have specific to the SAS code. That's what we thought. But I think, why not? You could pretty much have it in the SAS code as well.
Yeah, because it kind of brings up another question. What percentage of your users code in Python and VIA versus SAS?
So, I mean, again, just trying to understand, I think it's two different things, right? So what I'm trying to validate is, so SAS kind of like provided an upgrade, right? Newer version. I wanted to make sure, right? So I'll just give you one example, right? So it's not what the user is doing, right? At the end of the day, the user runs a SAS program, right? And that particular SAS program before upgrade took 5 minutes, right? Now I wanted to test the same thing, right? So it doesn't matter whether the user is clicking on it and running the SAS program after the upgrade, or me kind of like using these automation open source tools running the SAS program, right? It kind of like at the end of the day gives you the same, what you call, how much time it took, right? Before and post upgrade. So
Sorry to keep going. What you did with the 3 concurrent tests using the Playwright is supposed to replicate what happens in the real world with the users.
Yes.
That's correct.
The only difference being you're running your tests in Python, they're running it in SQL or SAS. I'm curious to know, have you ever done a comparison between what they do in the real world afterwards and then go back and look at your benchmarks to compare to see how close you were?
we haven't not.
Most of our SAS users use SAS data steps. So maybe 5% want to use Python. Python require more knowledge, development knowledge. The SAS, like a job-based or UI-driven drag and drop workflow is much easier for business analysts. Yeah.
Thank you for sharing this information. In your example, you were using SAS Studio, so it would be safe to say that we can repeat this, use the performance with other tools in SAS, say Model Studio or Intelligent Decisioning, just to make sure that the basic users, most of the users, can then work with proper efficiency on the system after an upgrade if everything is working out.
So my experience is, again, so my background is I'm not a SAS guy, right? Initially, it took, I kind of like recently moved to SAS 2 years back, right? If I can do it, anyone can do it, is what I think, right? So, so we did this in SAS Studio, and again, do we have users in Model Studio? No, right?
No, we
No.
don't
So, but
have a user. Model
I
Studio.
did the same experiment in the SAS Environment Manager as well. Like, because it's at the end of the day, I think it has an URI, right? SAS Studio, it's an URI. That's how I look at it, right? SAS Environment Manager is an URI. Like, I could go into the SAS Environment Manager, you pick a use case, and we could automate it.
So technically what
Yeah,
you did
so-
is essentially external to SAS. You can basically use the Playwright tool to test almost anything,
Yeah.
right? So
Yeah.
this is,
Yeah.
you're just doing it for SAS.
Yeah,
as an example.
all you need is, just think of it, right? Anything that you click in the web browser, you have an HTML, right? You have an API, right? I'm just giving an example. So why can't you automate it? It's an open source tool. It can understand what's going on within your SAS. All it needs is just probably, I think, in these DNA, I think AI could pretty much help you out. Pretty
Yeah.
much you could.
If I get,
That's the plan there.
if I could can I add one quick thing? We do have tests for SAS Visual Analytics and SAS Model Studio. Like Ishwar was saying, it's certainly doable. the one thing you have to consider there is when you're using like VA or Model Studio, you have to deal with the input data a lot, right? And so that's a little bit, it's doable and we've got that working, but it's something we're still working on is like, how do you feed in your data? Because the idea behind this is we want you all to run this using your own data, right? Your own tests to really mimic what the users are doing. So that makes it a little bit of a challenge, right? When you think of some of the other applications, but yes, we can do it, so.
I have one question. So you guys do the upgrade every stable release, or what is the upgrade schedule for?
So pretty much, I think at least twice a month.
So you skip
Well,
one?
Stable release.
Yeah,
You
stable
follow
release. Yeah.
stable, right?
Yeah.
But maybe you might be skipping a release and then doing it.
Yeah.
And is there any vulnerabilities related issues you guys face in your enterprise where you have to bypass before you can publish the release or push it to
Can
the
you
production?
put the
I
mic closer? I
couldn't
couldn't
hear
hear
you.
the question.
Sorry,
Thank
what
you.
I'm asking is, what about the vulnerabilities you find? Do you scan the image before you deploy, or that's not a requirement?
No, we don't scan it.
Okay.
So, I mean, I think most of us kind of like have a non-prod on production, right?
Uh-huh.
So we kind of like deploy it in the non-prod, right? Go through the similar exercise that we built on the validation test, do the regression testing against thousands of users. So if you see in there, we pretty much have the non-human ID accounts, right?
Okay.
Those are not the human ID accounts. So we kind of like have the non-human ID accounts pretty much kind of like kill the system. Like,
Okay.
you know, you kind of like do the best that you could, right? Do the regression test at it, and we are like, okay, so SaaS is living up to it. Then we kind of like move to the.
And for this test, you're not using the add-in for the SaaS, right? It's just a Python.
No,
you're not-
it's no. We are not using anything. Right. We
Oh.
pretty much, using those three, right? I said like Locust, Playwright, and then
And-
And the beauty of it is, you don't even have to have the browsers in there. Okay. So just for the visual representation of it, we did the browsers, but I could pretty much have this 100 plus users without the browser, right? You could pretty much run in the headless false mode, and it kind of like gives you the summary, but it probably takes some time. So, but you could pretty much do it.
Thank you. Thanks for sharing your work with us. It's really helpful for someone who wants to maintain stable releases and want to upgrade it. I have this question, follow-up question again with the release. Do you see any real benefit from sticking to the stable instead of LTS?
I cannot comment on that.
Can you closer?
ask it
I
again?
couldn't.
The question is, we have two releases. We have to make a decision whether we are sticking to the stable or the LTS, right? And due to the change management, making the production, what makes sense in production is to go LTS. And I see your production systems are stable.
Yes.
Right?
Yeah.
But is there any real user end benefit in going every month, upgrading instead of going every 6 months?
Do you want me to take that? Or?
So one thing, right? I told you before, right? Liberty Mutual thinks like a startup, right?
Yeah.
So they even plan like 10 months ahead. Like I think Eric could speak to it. The number of, in-house products that we want to kind of like have SaaS deliver to it as well.
Yeah, I think the difference really comes down to a couple things, right? How quickly do you want new features? And then security vulnerabilities.
Yeah.
How quickly do you need to patch your services because new CVEs keep coming in? If you're okay, well, I guess a third thing too is what kind of team do you have to do the updates themselves, right? If you're okay with the security vulnerabilities, that's not I mean, trust us, SaaS, we're addressing the security vulnerabilities,
we're
so
not.
don't think we're not, right?
No.
But if that's not as big of a concern for you, right, and if you don't need new features being delivered, then yeah, falling back to an LTS is perfectly fine, right? But in Liberty Mutual's case, they want some of the new features coming out. They're
Yeah.
that
Because we're in the migration phase, we want a new feature come in as soon as possible so the user can utilize that.
Okay.
when we, after migration, probably in the stable phase, we probably may change the RTS.
Got it. Got it. Thanks. Thanks a lot.